Okay. Okay. So this is just going to be just sort of a brush up, a refresher to fractions, adding and subtracting fractions. My sense as we've been moving into quadratics and all these fancy things in algebra, it just seems like your fractions are a little iffy, your understanding about fractions. And so I just think it's important to kind of refresh. And so that's what we're going to do today. Last week we practiced multiplying fractions, and then I threw a few curveballs by adding variables into those. Remember that? You guys remember that? Yep. Now when you're multiplying fractions, just before I get into adding, just to review, if I had, 16 over 24 times 8 over 12. What would I do again? Simplify. How would I do that?
You find what goes into the L.
Okay, so give me one, Oliver. Okay.
No, wait, that's at the lowest one.
Doesn't matter. We can do twos. Two out of what though?
Oh, Gary, I know. Oh, 2 off the top and the bottom.
All right, so off the top and bottom. Okay, so 2 goes into 6. So 16 divided by 2 is what?
8.
So I cross that out and I put in 8. 24 divided by 2. If I divide the top by 2, I got to divide one of the bottoms by 2, right?
Are you cross?
24 divided by 2 is 12. Okay.
Are you cross?
It's upstairs, downstairs, reducing. This is just multiplying right now, right? So before I multiply the numerator times the numerator and the denominator times the denominator, I am saying, is there a number that goes into a number upstairs that also goes into a number downstairs? 2, he said 2. Now, is there anything else?
Yeah,
You
4.
just do like 8 goes into 8 once, 8 goes into 8 once, 12 goes into 12.
Well, yeah, but you
No, but
you
you
can't
can't
do
do
8.
across.
You can't. If they're both upstairs, you can't do that. You got to do one upstairs, one downstairs, right? So, all right. So
It's
yes.
1/3.
Oh, 4 goes into 8 twice.
Okay. So which one? Doesn't matter really. I could
Eight.
use this 8. 4 goes into this 8 twice. So 8 divided by 4 is 2. 12 divided by 4 is 3, right?
They're both 2/3.
Great. 2/3. Good. Now, what else can I do?
You can do
Other
the same
side.
thing on the.
This is 8/12 as well, isn't it? So 4 goes into this twice. 8 divided by 4 is 2. 12 divided by 4 is 3. I've got 2/3, 2/3. What else can I do?
You wait.
Yeah.
1, 2, no.
How many times does 2 go into 3?
1. One time. Remainder 1.
Right. So there's not really anything with a whole number that I can do anymore. So now I multiply, right? There's nothing, I can't do 2s and 3s this way, or 2s and 3s this way, or 2s and 3s this way, 2s and 3s this way. They just don't work. So I got to now it's just 2 times 2 is 4 over 3 times 3 is 9. As long as I've completely simplified these, my final answer is totally simplified. And I don't have to simplify it. Now if I chose to just multiply this out, 8 times 16, oh my God, I have no idea, right? And then over 24 times 12, no idea. And then I have this gigantic number, and then I have to somehow reduce this gigantic fraction. Very hard. This is very easy. Do you see the difference? Right? All right. Now, did I need to have common denominators when I multiply fractions? Do you remember what common denominators are?
Yes.
What is a common denominator?
Downstairs are the same.
Yeah, both of the numbers downstairs. Denominators are downstairs, right? In order for it to be a common denominator, your two denominators would be the same number. Do I have to have common denominators when I multiply fractions?
No.
No.
What about?
Adding.
No, I don't here. I had 24 and 12. Those are not common denominators. But I was able to multiply it, but I first reduced, right? Okay. What about if I'm dividing fractions? So dividing fractions, let's say I did this. 4 15ths divided by, 2/5.
Well.
How do I do that?
Yeah, you do 15 over 4.
No.
Oh wait, 5 over 2.
Yeah.
Right, you always change this and then flip the second fraction.
Then it would be
So it would be
multiplied.
4/15 times, you guys remember this?
Yes.
Right? And then you flip this, it's the reciprocal, so it's 5 over 2. Okay, now I have my division problem became a multiply. You never solve them by dividing, you always turn them into a multiply. So what would you do? Help me, Sarah. Okay, so 5 goes into 15 3 times, 5 goes into 5 once. Okay, perfect. So we've got 2 times 1 over 3 times 1, 2/3. Yay. All right, easy. Did I need to have common denominators to divide fractions?
No.
No. Okay, good. All right, so dividing is always just turning it into a multiply. So what about something like this? 4/9 plus 5/9. Do I have common denominators? Do I have to when I'm adding and subtracting fractions?
Yeah.
I have to have the same denominators, common denominators. So what would I do? Once I have common, do I have them?
Yeah.
I have common denominators, so what do I do?
Yeah, they're talking about. I mean, at the both the tops.
So is it 9/18?
No, it's
No, no,
9
no.
over 9.
Right, so my final answer has the 9, the same common denominator in it. And now I just have to do 4 plus 5, which is 9. And I'm done, right?
No, you're not done. 1.
Yes.
Well, yeah.
Which equals 1, right. Okay, what about this? What if I gave you, I don't know, like 12/15 minus 7/15?
12 minus 7.
Do I have common denominators?
Yes.
Do I have to have them? Do I need them?
Yes.
Yes.
I need them, right? Because I'm subtracting fractions. So, what's the answer?
5 over 15.
5 over 15, and I'm done, right?
No, you have to
No,
simplify.
Okay,
1/3.
so is he right? 5 divided by 5? Are you trying to tell me 5 divided by 5 is 1?
Yes.
And 15 divided by 5 is 3?
No way!
Oh my God, you're right. Okay, so these are really easy when
Yeah, they
your
match up.
denominators are the same, when you have common denominators, right? Piece of cake.
Now you gotta.
Everybody has that.
decimal.
Figure out how to.
And now we're gonna do something, we're gonna do them where they aren't the same, and we gotta figure it out. So we're gonna create a little rule here, okay? A little thing, a step-by-step thing. The first thing is, do they have with an F, have common denominators? Okay? So do they have common denominators? So here we go. We've got 2 6 plus 3/12. Do they have common denominators?
No,
No,
but you can simplify.
But you can, time?
No, you simplify to 12. Into a
So
6.
so
Oh,
what
yeah.
would you say the common denominator could be?
Oh wait.
Um,
Oh wait.
you,
Should be.
you,
You were right.
what?
3.
Well, now you're
No.
wrong. You were right, but now you're
2.
wrong.
6.
You
Well,
cross
either,
multiply.
you could either, it would be best if it
It'd
was
be
12.
6 plus,
It would be-
3 6.
All right. So I'm going to suggest that we just
Do
look at the
12.
smaller number. This is my second thing that I suggest. Yes, there are different ways to do these, right? Some people might have said change 3/12 into 1/4 because you could have done that, and then, but you're still going to have 4 and 6. They're not going to be common denominators, right? So this is what I suggest. Can you? This is the second thing. Can you multiply the smaller denominator by something to get, well, to equal larger denominator. Does that make sense?
Yeah.
I'm not going to try to make my larger one smaller. So that just don't ever try. I mean, don't think of that. Think in that way. Always look at the smaller one. Can I multiply 6 by any number to turn it into a 12?
2.
I can, right? 6 times 2 is 12. Oliver, you agree? Right? So this is what you do. You put a parentheses here and a fraction line. Okay? And you put 6 times what is 12? 2. So if I put a 2 downstairs, I have to put a 2 upstairs. Whatever I put downstairs has to be the same thing upstairs. All right? So what does 2 over 2 equal? 1. So I'm going to be multiplying 2 6 by 1. But by it's a weird one, right? It's not just 1, it's 2 over 2. And it's going to change the way 2 6 looks, but it's not going to change its value. Because 2 6 times 1 is 2 6, right? It's just that when I multiply it out, 2 times 2 is 4. 2 times 6 is 12. Plus 3 12. Now, this does not look like 2 6, but this is the same thing as 2 6, because I only multiplied it by the value of 1, right? So I'm just manipulating by using weird ones. I call those weird ones, okay? And so suddenly I have common denominators, right? Right? So now I can add them. What's my final answer? 7 over 12, right?
Oh, that's cool.
Does that make sense?
Do you always have to do it by 2, or can you do it by a different number?
Okay, well, let's try. That's a good question.
Wait,
So, do you have this one written down yet? I'll just do another one here.
If you
So,
can do it by the denominator,
You have to
So,
do it by-
um,
can you do it by anything?
4
you can do it by anything.
thirds minus 5 ninths. Do I need to have common denominators for this one?
Yes.
Why?
Because it's subtraction.
Right, exactly. Okay, now, first thing, do they have common denominators?
No.
No.
Nick.
Secondly, can you multiply the smaller denominator by something to equal the larger denominator?
Yes.
Okay, by what?
3.
3. So I'm going to put my parentheses here. Parentheses always means multiply, right? And 3, okay, I'm going to put my fraction line. 3 times what again?
3.
3 times 3. So if I put a 3 down here, I got to put a 3 up here,
3
right? 3 over 3 equals what? 3 over 3 equals 1. So I'm only multiplying 4 thirds by 1, but it's going to look weird.
Yeah.
It's going to look totally different. 3 times 4 is 12 over 3 times 3 is 9 minus 5 ninths. Now do I have common denominators? Beautiful. So what's my final
6
answer?
ninths. Wait, you could simplify that, right? It's like
Well,
2
what's
thirds.
we're at 12 minus 5?
6.
That's 11 minus 5.
Oh, 7.
Right, 7
Do
ninths.
that.
And can I simplify that any further?
No.
No.
Wait, no.
Because nothing, 7 is a prime number, right? Remember what prime numbers are?
Yes.
1 and 7, that's it. Those are the only 2 factors, right? Well, not
I
yet.
messed up.
Not yet. There's one more rule, okay? There's one more rule coming. So should we do another one like these though? Let's do.
Let's do
let's-
hands-on stuff.
Okay. What time is it? Okay, one more like that. I just want to be sure we've got it down. So how about I say 5/14 plus 1/7.
Ooh.
All right. Do I need to have common denominators for this?
Yes.
Yes, no, Oliver, yes, no? Una, yes,
Teacher.
no?
Teacher. Teacher.
Why?
Teacher.
Why?
Teacher. Teacher.
Look, I already know the
Wait,
answer.
shh, guys. Right, exactly. Whenever you're adding or subtracting, you have to have common denominators. So, using my first rule, do they have common denominators?
No.
No.
No. you didn't, Teacher.
Okay, somebody different.
What? I'm different.
Teacher.
I haven't said
I am different actually.
Teacher.
Okay, Cassius.
Do they have common denominators? No. But can you divide?
No, the
You
question,
guys-
what's the second question?
I know.
Can you multiply?
I know.
Don't think of dividing, think of multiplying.
Teacher, I did
Okay.
that on the Are you proud of me?
Have a seat, just seat you on the tie.
The answer is 1/2. Teacher.
Okay, so go ahead.
Teacher.
Do you do it on? You can do it on the other side.
I can do it on the other side. In this case, where's the smaller one? The smaller one's on the right side, no big deal, right? Is there a number I can multiply 7 by to turn it into 14? All right, so I'm gonna put my parentheses now on the right side with my fraction line. 7 times what again, Cassius? 2. And then if I put a 2 here, I gotta put a 2 here, because there's my weird 1 again. 1, okay, so now I'm gonna rewrite this. 5 over 14 plus 2 times 1 is 2, over 2 times 7 is 14. What's my final answer?
7 over 14.
Can you divide
Or
that?
14.
Where'd
It's
you
one
divide
half.
that
One
piece
half.
into two?
One half. One half.
I
Hold
have
on.
broken
One
the
half.
laws of
One half.
physics.
Teacher.
It is two.
Teacher. Teacher.
That's the answer.
2.
Teacher. No,
Right?
it's not. Teacher. It's 1/2. Teacher.
Never
That's
mind.
2.
Teacher.
I felt so happy.
Hey, teacher. It's 1/2.
You have the right idea, but
Teacher.
remember, this is so common.
Gary, what happens when you flip a paper?
I have this happens to me.
That's
Almost every time I do fractions with you guys, and there's homework, fractions and homework, people will see that and they'll say it's 2. I mean, I have it happen all the time. Don't do it in your head. Say, you actually have to cross something out and replace it with something. 7 divided by 7 is,
1.
so you cross that out and you put a 1.
And then 7.
14 divided by 7 is 2, so it's 1/2. But if you do this, you guys listening? If you cross things out instead of doing it in your head, you won't ever make that mistake.
Would that be the
That's
answer?
calling that 2. You would always know it's 1/2.
1/2 would also be the answer too.
Yes, so 1/2 would be the answer, the correct answer. Okay, so those 2 rules were great for those, right? All right, we got one more rule.
Wait, teacher.
All right, here we go. We got 1/3 plus 2/4. Okay, first rule. Do they have common denominators?
No.
No. Okay, second rule. Can you multiply the smaller denominator by something to equal the larger denominator?
No.
No.
No, you can't. So we need another rule.
Yeah.
Okay.
We use
Um,
Calculus.
If both, well, how do you say this? How would I say that? If you, how do I say this?
if both fractions don't have a common
I don't
denominator
know.
or
Yeah, I
can't
don't
be
know.
multiplied,
Right.
multiplied by a.
How about if I just say, if not number 2, then, is that okay?
Yeah.
You get what I mean? Then what? Then multiply both denominators to get a common denominator. So we'll try a few of these and see. How would that work?
You would put 4 on the other side.
What would my common denominator, there's lots of possibilities, right?
Teacher.
What?
Teacher. I know the answer,
Yes,
teacher.
William.
12. 12,
Did he
teacher.
tell you that?
No.
Okay. All right, so do I have a 12 right now in the denominator at all?
No.
Guys, we'll just let it be. All right, that means I have to have fractions on both sides. You agree with me?
Oh, that sucks.
Right? And so 3 times what would be 12? So 4. So if I put a 4 here, I got to put a 4 up here.
The other side is 3.
And 4 times what? Times 3. If I put a 3 here, I've got to put a 3 up here.
All of it. No.
With me? Do you see why? Is
Like,
that,
just like do like
Yeah.
the number from a different
guys all see it, right?
to there.
Yeah.
No,
Makes
but then
sense.
sometimes the number will be too large, and so you have to go with this the smallest number that they both are factors.
okay, so everybody understand what I did here?
Yeah.
Why? Okay,
Yeah, it's
so
really good.
4 times 1 is 4. 4 times 3 is 12. Plus 2 times 3 is 6. right? Over 4 times 3 is 12. What's my final answer?
24.
4/5.
Oh, we're not multiplying.
Let's do homework now.
10 twelfths. Wait, we got to do one more example.
It's true.
All right,
5/6.
which is divide by 2, divide by 2. It's 5/6, right?
Oh my god.
Nice. Okay, last one. Last one, just to practice. Okay, how about uh,
Like, what?
4/6 minus 1/8. 4/6 minus 1/8.
No, I know it
Okay, Max.
Teacher.
You do,
No, it's
All right,
not gonna be
do they have
perfect.
common denominators?
no.
Oh,
Can you multiply the smaller to get the bigger? No. So we have to do 3. So none of those work. So we've got to do multiply both of them. That means I can immediately put my parentheses here. Immediately put my parentheses here. My fraction line. What two numbers do? What number do these two numbers go into?
They
oh,
both go into 24,
No.
whatever 6 times
right?
it is.
Well,
No.
what were you gonna say?
Well, I
Yeah,
was
they
gonna say,
both go-
you can do 8 times the 2 6s on the top and bottom, and then you can do 6
Me
times
too.
2 8s.
So yes, both of these guys are right.
It's
So
6 times
this is important to understand. In this case, I could choose 24 as my common denominator, or Max was suggesting 48. That's fine too. It's usually easier when you have you choose the smallest common denominator, right? But it's not a big deal. Guys, this is an important part of the lecture. If you're confused and don't know, then just say it's 6 times 8. This denominator times this denominator. You know that these two numbers go into 6 times 8, right? Because you got the 6 times 8 is 48. You know they go into 48 because that's how you got 48. You multiplied them together. So 48 would work. 24 would be easier, perhaps. But let's do Max's idea of 48 and see. Okay, so we're going to make 48 our common denominator. What would I have to multiply this 6 by?
8.
8, right? So if I put an 8 there, up here I got to put an 8. What would I multiply this 8 by? 6. So I got to put a 6 up here. All right, what's 8 times 4? 32 over 48 minus 6 times 1 is 6 over 48. What's my final answer?
Oh,
24 over 48.
Almost.
Wait. No. Yeah,
26.
26 over 48. I knew that. Teacher, I'm smart. Teacher, are you proud of me?
26 over 40. I'm so proud of you.
Yeah.
26 over 48, right? What? Okay, so Luke is dividing both top and bottom by 2. So 13 over 24. And I think that's about it.
I
See,
got
if
it.
we got 24 to start with, that would have been
All right.
right. Teacher.
Now, fist of 5. Did you guys all write these down?
yeah.
For sure?
Well,
Fist
Is
of
it
5. I
red
just want to know if you understand this stuff.
oh yeah.
Makes sense to you? Good. Awesome. Okay.